here we are at our metalworking Leblonde lathe again. Today is going to be our second demonstration on the lathe, and we're going to be looking at how to change our feeds and our speeds in relationship to the chuck RPM and the tool post movement speed. This tends to be a confusing part for students because we have a half a dozen or more knobs and levers and charts that we're going to be looking at today to be moving those things around. So hopefully we can reference this video to understand a little bit better when the time comes as to how to set up those settings for proper cuts on the lathe. So first thing is, how do we set up the RPM on the chuck? Well, and then this is going to be a little difficult with the angle we have on the camera, but I'm going to try to get in as best as I can on some of these different areas today. So please have some patience. This top half set of levers right here, these four, are in relationship to the RPM of the chuck. So if I turn the chuck on, it's spinning at 1,000 RPM right now, which is pretty fast. If I want to slow that down or speed that up, these are the different RPM values that I can set the chuck to. So anywhere from 40 to 2,000 are the different RPMs I can set the chuck to. Now for the most part, we're going to be just playing up here in these top RPMs. For the most part is where we're going to be. But we can adjust our high-low, we can adjust forward-reverse if we needed to, but generally speaking, all we need to adjust is these two levers, which is going to give us anywhere from 40, 60, 100, 165, 245, 375, 625, or 1,000. There is a note here: do not change spindle speed while spindle is rotating. So we do not want the chuck spinning when we're doing this. It should be stopped. All right, we've got letters C, B, A, D. Those are going to correlate with A, B, C, D and A, B, C, D. So we have two halves of this chart that we can deal with. Depending on which A we're in is which setting this knob is in. This knob has two settings, a high and a low setting, and it's hard for you to see over there, but the knob has two lines coming off. And this upper line follows over way over here, which is telling us when we're in the upper line, which should be right here, we're in this half of the chart. So we're really low RPM in general. So the only time we're probably ever going to be down here is when we're knurling, trying to get that grip on the hammer handle. Most of the time when we're cutting, we want to be in this half of the chart, which is going to be the bottom line, which comes to these four. So now that I'm in the bottom line, I'm either in 245, 375, 625, or 1,000. According to whichever letter I'm in, I happen to be in letter D here, so it says I'm at 1,000 RPM. If I want to switch for cutting at 625, I would need to be at C. So now I'm at 625. If I were to turn it on and check, that is definitely slower than what it was at 1,000. If I want to go to 375, that would setting B. And you'll notice I'm usually giving the chuck just a little bit of a spin by hand when I'm trying to connect these, right? Because everything's gear driven, not always do the gears line up perfectly when we're trying to make a connection. So sometimes it just takes a little wiggle to get that to lock into place. If you're ever not sure, did it lock in, we can always hit this jog button down here. And if it's in, it's going to spin properly. All right, so I just moved us to B, which should be 375. And that's even slower, and so on. So that's working. So for setting our RPM, it is these two levers right here, and following the letter pattern, A, B, C, D, or A, B, C, D, and then depending on which half of the chart, left or right, depends on which position this knob is in. So hopefully that's going to help you. And I didn't touch any of these over here. For the most part, These are the only two levers that we need for the average cuts of what we're doing. So for cutting aluminum, most of the time, we're just going to be in 1,000. All right, so for aluminum, for our hammer handle, we're going to traditionally be in 1,000, which is D. Okay, so that's RPM, how to set the speed of the chuck. And for aluminum, we're going to be running 1,000. If you were running steel, you're probably going to be running the 625 mark. If we're knurling, we're probably going to be down here in 100 for knurling RPM. All right, so the second thing then is how to adjust how fast or slow the tool post is going to move. So I'm going to zoom over here a little bit. And we're going to turn it on. And when I run the automatic feed, right now it's moving to the left or towards the chuck. And how fast or slow that's moving is set up by these lower dials and knobs over here. So let's take a look at some of that. And this, I don't know how well you're going to see. This big chart. These first three sets of charts here have to do with threading. So threading, threading, threading. For the most part, this is if we were trying to make threads per inch, which we're not going to do in Machine Tool 1. So we can ignore the first 2/3 or 3/4 of this chart. We're just going to concentrate on this portion of the chart right here, the last one. This is going to be basically your cutting speed or your chip load as we go through here. So we've got metric on the left side. We've got inch on the right side. Traditionally, we're using inch in our class. If you want to convert to metric, so be it. But we have inch here, so we've got a number of 0.002, 0.009, 0.067 way down here. Essentially, this is the thickness of the chip that you're cutting. So if we take this particular cutoff right here, all right, so this was broken off as we were making a cut. It's a chip. And if we were to measure the thickness of that chip, that would theoretically be whatever this number is set to on the lathe. So if we think about that, if the chip is super, super thin, means this is probably going pretty slow. And that would be a number way up here, like 0.002 would be the slowest we can go. If the chip was really thick, like we were hogging that material, it'd be a big number. The thickness is a big number, and that means that the machine is going very fast in regards to speed of the tool post. Not RPM, that means the speed of the tool post. We traditionally like to play somewhere in the middle of this chart. You can speed it up a little, slow it down a little, but we're traditionally not way down here. This is really fast for what we're doing. And we're traditionally not way up here because it just takes forever. So a good range for us is anywhere from 4 to like 9 thou for thickness of our chip for what we're doing. So let's take a look at 9 thou. If we come over to the middle, it's got some letters and numbers. LCR2W matches up with 9 thou. LCR2W. Well, here's C. Oh, I got to zoom out. So the bottom half, all these knobs down here, have to do with the feed rate. I mentioned the upper knobs have to do with RPM, the chuck. These lower knobs have to do with our feed rate of the tool post. So LCR2W. Here's C, ABC on there. ABC, we're in C. LCR, so here's RST, kind of hard to see the T. So we want to be in R. And if it's not connecting, we may have to adjust the shaft a little bit. So there's R. And then, where were we? 9 thou. LCR. So L is just referring to low, which we're going to be in pretty much all the time right here. So we really don't mess with that one. And if you are messing with it, we have to be careful that we're not going into high. above 330 RPM, and it says it right there. So for the most part, we're not messing with that lever generally. So LCR 2 right here. So there's 2. That's got numbers 1 through 8 on it. They just, I don't know what number you're supposed to go into, so there's 2. And then W, LCR2W. So again, we got another set of levers here. Just make sure you're clicked into W. And if we hit the jog button, what we should see spinning is this bar right here. This is our automatic feed bar. So if everything is connected correctly, when we jog that, that's spinning for us. I don't know if you can see that or not, but it'd be the bottom one. The top one is threading. We're rarely threading in here, especially in machine tool. So we just want to make sure if we're connected, that's going. So if it is, when we turn it on and engage your automatic feed, it's now going at 9 thou chip load for our speed. It's really hard to understand right now, so let's go to an extreme fast setting, and then we'll go to an extreme slow setting and try to look at that concept. So I'm going to come way up here to, or down here to fast. Let's go to LCR 8X. CR X 8. LCR 8X. So there's extremely fast. I'm going to come back here. You can see by how fast the handle's spinning compared to before. LCR 8X is 33 thousandths, which is basically a 32nd of an inch chip load. Extremely heavy pass. We would not be running this fast, but I just want to show. And the RPM is still at 1,000. That didn't change. All right, so let's go to a really slow one. Let's go to LCT4W. C LCTW 4. And now we can see how much slower this handle is spinning in comparison to what it was before. So again, a quick summary. The top half here, these two knobs mostly, are going to be controlling our RPM. We're typically going to be in 1,000 or 625, so you're going to be in C or D over here, and you're going to be on the bottom line to get to this half. We're already set at 1,000. Down here, we want to get to a mid-range number, like 9 thou is a good setting, and that's at LCR2W, so C, R, W, 2. So that would be setting up to a mid-range chip load of 9 thou, LCR2W, and we're ready to start doing our cuts. We talked in the previous video about how to put the tool in the tool post, how to put the part in the chuck, how to turn it on and engage the automatic feed for cuts and change the direction of our automatic feed. We talked about some of the safety protocols, keeping the e-stop. We have a brake, we have a kill switch on the guard so it doesn't work, keeping our fingers away from the chuck and the cutting surface as it's cutting. Today then we talked about how to set up the machine properly. And the next video we're going to be digging into on the lathe, probably the final one, is going to be actually making our hammer handle. That video is going to be a little bit longer because it takes a while to get through that project, but hopefully this is going to get you started in a better understanding and a little more confidence on using our Leblonde lathe here at Watertown High School.